Okay, so we've started recording. Hi, everybody. I'm glad to have you with us this afternoon. Today we're going to do the fifth session in the Rust BuildOn series, and we're going to focus on integrating the parts we've built so far. So we built the TextSearch, we've built DirNav, we've built CmdlnParser, and now our job here is to tie it all together and get it running as a functional unit. So I'm going to talk a little bit about my command line parser, and we're going to talk about Rust macros as a part of our Rust technology discussion. And before we go at the end, I want to talk to you a little bit about these extensions. I had mapped out adding regular expressions for the text search and adding parallel text search, and I want your opinions about, how valuable you think that might be. Okay, so let's start by looking at my solution code. So this is a command line parser. And my design, let's look at this first. This may help understand. My design was to try to break up command line parsing into a totally reusable part and an application specific part. Clearly, there has to be some application specific stuff because each program has a particular set of attributes it's looking for from the command line, and they're different from program to program. So what I did was, my model is that I'm going to walk down the command line, and every time I see a backslash something, that is an attribute. And if I have a key that matches that attribute, I add whatever when I take the next, so that when I hit that attribute, that becomes the current attribute, and then I step, and if the next item is not an attribute, it's a value, then I just add it to the hash maps value vector. It's a vector of strings for that key. And then, I walk down the arguments, and then if I hit another attribute, if I already have an attribute, it simply, if I already have that attribute, it simply adds any additional values into that attribute's vector. And so the model is really simple. I'm just walking down the command line, making attributes keys in the hash map, and making anything that isn't an attribute a value of the last key I've seen. Okay, so nice, simple, fairly easy to put together, and but now to make it application specific, I have this set defaults. So what I do is I parse the command line, and then I call these functions for this particular program. Here's all of the attributes that I want to have default values for. So a path has a default value of dot, the current directory. And the little p has a value rs for the extension of, this is a pattern, it's extension of Rust files. T is whatever text, and I make it empty, so that'll pick up, every file will be successful with that default. And then H stands for, do I want to hide any directories that I don't have any matches in? And that normally is what you want to do, because very often you'll process many more directories that don't have matches than directories that do have. And so the successful results will get buried in this avalanche of uninteresting stuff unless you hide all those directories with no matches. V is verbose. It's going to print out a little bit of stuff when the program begins. And S means I'm going to recurse, and the default value is true. But if I set this to false, then I'll only do the current directory. So what happens? What happens here is I parse the current directory, and then after parsing it, I set the defaults. And so, if I already have something that has a default value, I don't touch that because the user entered what he wanted. But this allows the user to enter very little and get default behavior, very sensible default behavior. So it's a nice, simple way of breaking up this design into a nicely reusable part and a application-specific part. So let's see. Let's look a little bit at the implementation. I'm going to whip through this pretty quickly. My mental model is that it's here, this code is on the, in a directory available to you now. I'll show you where it is as soon as we get done talking about the code, And so I'll go over it quickly, but you're welcome to ask questions and slow me down if you want to. So here's my parser. I have a hash map that holds a string and a vector of strings. So this could be a character. It would work just as well the way I'm using it if this was a character. But having a string allows me to add, use parameters that have meaningful names. Normally I don't. Normally I just use the character version, but I could do it either way. And now here I'm implementing the command parser. It doesn't have any traits other than the derived traits debug and default. Default just says that, people can create an instance of this command parser and give it assume its default state. And basically what happens with this, when I derive the default, it's just going to use whatever I use for new will be also used in the default. I allow you to set arguments in the command line. So if a program wanted to, under some conditions, set additional arguments, you can. And then parse is what collects the command line arguments. And so, if args is empty, args is what I'm reading from the command line. Okay, args is all my items on a command line. If that's if that is currently empty, then I collect the arguments from the command line. If it's not empty because I set up, or the user set up, some test cases for the parser ahead of time. And so if that's the case, if it's not empty when I'm first starting out, when I'm first creating this command line parser, then I just collect arguments from the command line. So for item and self.args, here I'm stepping over the args. I'm testing if I'm iterating through the characters on this first argument. And if the first one is a backslash, then I collect the rest of the characters, in case I'm using instead of saying capital P, I say capital P-A-T-H. Very often this will already be done. And then if the entry has no value, I want an empty vector of values. So when parsing is done, every attribute has a vector of strings. Some of them may be empty. And that makes it easy then to set the defaults, because I don't have to go around setting up the new vector. The vector's already there. So if I've collected at least one attribute, then I push the value. So if I've already collected some, I just push the value onto the back of the attribute. I have a function called get, which gets the value of a given key. You give it the key, and it returns the value. And I can return. So this returns an option of vector strings. And there's also a get mute, which returns an option of a mutable reference to the vector string, so I can change it if I want to with that. Function, do you contain this key? Get parse just goes and grabs the hash map out of the command line, just returns the whole hash map. I don't think I've ever used this, and I might remove it because it's a vector for bugs in a if somebody doesn't know what they're doing. So I probably will remove it. But anyway, I had it in here because I used it some when I was testing it. Okay. And then I have a set default. So if there's no entry if the key already exists. So if it contains the key, I just return. And now I'm using the fact that Rust returns whatever value of the expression is in that scope. You don't have to specifically say return. And this is going to return a unit value, the pair of parens that signifies nothing. Otherwise, I insert the key and the value. This is the key and the default value is what I'm setting. And here, after I've parsed, if I had a /h, they show up empty, and what I do is I set them to true. So if it's there, a parameter like h is just a Boolean. It says I want to hide unmatched directories, or I don't. And so instead of leaving it empty, I just if I see it, then it evaluates to true by definition. So just a simple invariant that works. So and I have a insert function and replace value function. So function to show the arguments, function to show the parse, and then some unit tests. So if I say cargo test, it just runs the unit tests. And here I'm going to say cargo run example test2, and now /p ... So I want to start at a directory above my current working directory, and /little pattern rs /text struct /little p again, just to show you how that works, h and cpp. So now here's what happens. So after I'm done parsing, I'm looking at the command line parser, just printing it out so it shows me everything. So here's the path, ... Here's the little patterns, and notice it grouped them all together. Just, even though I listed them as in two separate p attribute statements, it all just works. I could list them all together. I could list them separately. A lot of times I'll list something and I say, oh yeah, I want to look for this file as well. And I could just tack it on the end. And then here's my text for struct. And then I'm displaying, I hold on to all the arguments that was passed. This was mainly for testing. I think that probably could be yanked out now, but I did it for testing. And so after I set the defaults, so I have P, now I have S as true. That means do recurse. I have verbose as true. That means show a little bit of information at the beginning of the run. And and here's my patterns, here's my text, here's H is true. Okay. So you can see what the set defaults did was it set this, it set this, and it set this. Okay. Piece of cake. So that's the code. And the solution is here in Jim Fawcett BuildOn. And here you see BuildOn solution 4. So if when you come to BuildOn, you'll see BuildOn 2 solution, 3 solution, 4 solution, and that's what we're looking at now. This has the command line parser. So if you want to, you want to pull out my code and look at it, that's where you get it. This is a public repository. I have a private repository called BuildOn Private that I have my complete solution, but of course I made it private so that you would have some motivation to actually generate this stuff yourself. Okay, any question about that before we move on? Everything makes sense? Makes sense, Vaibhav?
No.
Yes, Dr. Fawcett.
Makes sense, thing? Yeah.
Yeah, looks good to me.
Okay, good. All right, step 4, executive. So now comes the fun part. We get to tie everything together. And, you may have already been tying stuff together as you go. That's normally not what I do. I normally develop as much as I can bottoms up, each part kind of in isolation, and then I tie them together. If you start tying them together right from the get-go, right from the beginning, it limits how you can test it. Because if I got, TextSearch and I'm driving it with DirNav, that limits the inputs I can give to TextSearch to test it. So I typically do these piece by piece, and then I tie them together. Eventually you'll get to the point where something needs a whole lot of data, and then you'll tie it together, But anyway, so your job now is whatever you haven't tied together, tie together. And I've talked a little bit about executive here, some notes. Now, the way what you do in executive depends on the design you decided on. So if you remember, we talked about these different design strategies. So, in this executive, the executive does everything. Here's a factored executive. The executive is just calling into the parts. The data flow executive sets up a data flow chain, and the type arrays adds to that the dependency inversion principle, the scaffolding, the traits, and the object factories to implement dependency inversion. And the plugin finally, it actually undoes a little bit. Here in this case, this guy, DirNav, is templated on the trait for, it's templated on a generic parameter that has to satisfy this trait, where this guy will be plugged in. And this guy, the TextSearch, is generic on a type that has to implement the search event trait, which the output display or the gen out will implement. So in the plugin form, we removed the parameterization of the output from here because we wanted to be able to determine this type at runtime. And you can't do that if he's a generic parameter here. And so that changed the design a little bit, And I've got an example. You could go to the code for these, the design, and it's doing very, very little. There's very little computation and input and output. That's very simple. It was just done that way so you could see what it takes to build each of these structures. Most of what you see is the scaffolding to build these structures. So what you do here depends on the decision of the type that you want to use. I kind of pushed you to the toward the type erase. A plugin is fine too. I didn't implement plugin myself. I did it for the design bytes, but in my own solution for this project, I used the type erase, the dependency inversion principle throughout. Okay, so another thing about that is, where did I put it? Oh, I know, it's in the examples. We'll come back to these displays in a minute, to the BuildOn steps in a minute. So project structure, I'm highly recommending you use a project structure like this. So you have an application directory and all of the parts, including the executive, are on the same level. And the reason for that is that the dependencies are recorded in these cargo files, and it's really easy to keep track of. If I need to depend on this guy, I just, in my cargo file, I go up one level and then down into that directory to pick up that dependency. So the path statements are really simple. If I build a hierarchical structure, then I got to keep in my head that structure as I'm laying out the dependency paths. That's much more complicated. It's really simple just to do it this way. I don't see any downside to doing it this way, and it makes it really simple. So, you know, it's up to you, but that's my my take on that. We already looked at design bytes. You know, we've looked at the cargo dependencies. I've shown you that dependency inversion inverts the dependencies and so on. And again, you can get to the code by going to BuildOn, and then here's the code for the command line. The only code that isn't here is the code for my complete solution. And next week, that'll be in 2 weeks from now, that'll be there. Okay. Now, are we ready to talk about macros? Okay, let's talk about macros. You ready, Mike? Your sound is off, but that's okay. Okay, macros. So, is that big enough, Mike? Thumbs up if that's big enough. Okay, good. So, I don't want to look at the details of this yet. We will look at these details. I just want to make a point. I can define a macro locally, like I did here. Here's a macro definition inside this function, and it automatically captures any local data. If I mention here, I'm mentioning offset, which is not defined in the macro. It's defined in the same scope as the macro, and the macro uses it. Okay. That's good news and it's bad news. Okay. The good news is that I can now use these macros like cut and paste. If I got some place where I have exactly the same code that that uses some values out in that scope, I can just write the macro and I can paste it wherever I need it and save writing some code repetitively. You know, the same piece of code over and over and over again. The bad news is that if you're not aware, either you paste it someplace where it doesn't have offset, or you don't want to change offset, but this guy changes it, you know, then that's bad news. So one thing that macros buy you over functions is that a function defines its operational code in a child scope. A macro defines its function in the main scope. And you really want to understand that to understand how macros work, okay? Um, uh, so, normally we don't think about it, and most macros don't use any of the captured scope. I think typically I myself would write macros to trying not to use it, but when you need it bad. The other thing that macros are good for are to build variadic operations. So here I say variadic macro 1, 2, 3, 4, 4 arguments. Here I say variadic macro ABC, 3 arguments, and it works just fine. There is no way in Rust to build a variadic function. That's done in C++ with templates, but Rust generics are more like C# and Java generics than they are C++ templates. You can't do that recursive processing that the C++ templates do to give you variadic arguments. So the upshot of it is, if you want variadic arguments, you got to write a macro. And don't worry about the processing here right now. We'll look at that. So here's the way. Now, by the way, there's 2 versions of macros: declarative macros and proc macros, process macros. And I'm not going to talk about proc macros. Proc macros were added just about the time, they were added in 2018. There isn't a whole lot of documentation on them, and they seem to me to be a bit more complicated than declarative. Declarative macros are pretty simple. So I have pushed proc macros off as something I want to know about, but I don't need to know about them now. I got other things I want to work on, so proc macros are going to take a back seat for a while. And proc macros I think are something that you're not likely to use a whole lot. So for declarative macros, here's the way it works. They start with macro rules with an exclamation, with a bang, and the name without the bang. When you use this macro name, you put the exclamation point, the bang, here. But in the declaration, you don't, because macro rules are the macro rules is a macro. Okay, so and the way it works is it has a series of rules, and the macro only fails if every rule fails. The expectation is that many of these rules may fail, but one will succeed. And we'll see how that works. And each rule has the form pattern causing an expansion into Rust code. A macro is a generator for Rust code, in the same way that a generic is a generator for code. Very, very similar, So here's our first one we're going to look at. So here's macro rules, indent print. And all I'm going to do is indent my arguments. A new line and a couple of spaces. So here's my first rule, and here's the pattern. $a.expression. Now the $a tells the macro, this is an argument that's going to come in from the argument list of the macro. And not everything is an expression, as we'll see a little later on, but most macros use expressions, because expressions are pretty broad. They cover a whole lot of ground. So a expression goes into print $a. I'm just going to print that expression. Whatever it is, I'm going to print it. If it's a struct, I can print it. If it's an identifier, I can print it. If it's a literal, I can print it. All of those things are expressions. Here's the second rule, empty. And I'm just printing out print with no argument to print. So now when I call it, I say indent print. This is a demo, and then indent print. And the first one matches the first rule. This is a demo. And the second one matches the second rule, no argument to print. Now you know 80% of what anybody knows about declarative macros. But there's some cool stuff coming. So here's variadic macros, and the way variadic macros work is you wrap the arguments, anything you want to have multiple occurrences of, in a $paren star or comma star. Star says there's 0 or more repetitions with no separator. Comma, 0 or more with a comma separator. $+ repeat 1 or more instead of 0, 1 or more with no separator or with a separator. I don't know whether you can use, I haven't tried using some other kind of thing for a separator. Wouldn't surprise me if it doesn't work. Wouldn't surprise me if it does work. So, but anyway. So here's my multi-argument indent print. I'm going to do the same thing, but now I'm going to add I'm going to add variadics to it. So my pattern matches format expression. This tells me how to format. So here's my format expression. It tells me how to format the print. Okay, followed by 0 or more expressions. So format expression, and then here's my repetition, and inside what I'm repeating is the argument, an expression argument. And now here, I'm going to cheat, and I'm just going to pass it directly to print, which is already a variadic. So my expansion, I'm not using any variadic processing for the expansion. I'm just handing off my variadic arguments to a variadic function print. Variadic macro print, okay? Does that make sense, guys? Does that make sense?
Yes, Dr. Fawcett.
Okay. So, and here I'm using it, let s equals string from Rust, ma print, here's the format, and then high 42s, and it prints out high 42 Rust. And now, and then I just print s to show it, that's all, Rust. Okay, so now, that's great, but let's see, how do we expand the, most of the time we don't want to hand our variadic arguments, we don't want to expand them into, just pass them to a variadic function. We want to expand them ourselves, and that's what the next example does. Now, and it's kind of a cool example. These things that look like they are, it's very similar to the Rust argument syntax. I pass an argument name colon a type. And now in a macro, what you're passing it is a name colon category. It's not a type. Okay, expression is not a type. It's a category that contains a whole bunch of a whole bunch of types, or literals, or whatever. So, but a fragment, when he says fragment, he's talking about these guys right here. What can go there beside expressions? Well, expression, of course, a single identifier can, a type, string, vex string, a path, a pattern like this. These are patterns for, you can put that, a literal, and the most interesting is a token tree. And a token tree says, stuff. Whatever stuff you give me, as long as it's compilable code, I'll run with it. Okay, and we'll see how that works. So I'm going to build a timer macro. Let's get this up a little bit. So macro rules, time IT. And now I'm going to measure the time to process the token tree, whatever's on the token tree. So context literal, this is just a statement I'm going to print out so the user remembers what it is he was timing. And then the token tree, one or more token trees. And then now I'm going to expand it. Here I'm in the expansion part. Let timer equal standard time instant now. I start the timer. And now I am expanding. This is just taking these in sequence, token tree after token tree after token tree. And then when I'm all done, and what I'm really doing is I'm invoking each of those token trees. Anything that's invocable, I'm going to invoke. Let timer t time elapse. I'm stopping the timer, and I print out the time. I have another rule that does everything, but I yanked out all of this stuff because I want to know how long it takes me to use the scaffolding without timing anything. So what you'll see on Windows, the timer, the smallest thing the timer will return is something around a microsecond. And this tells you, for the platform, this is the smallest thing that the platform can provide, the smallest time interval that the platform can measure. And that way, you can tell, am I looking at junk or am I looking at some good results? If it's really close to the scaffold time, it's probably junk, just down in the noise. But if it's significantly above, 10 times, 100 times above the scaffolding time, then it's probably good results. So let's look at how we use it. So here I just defined a couple of functions, a doSleep function and an open file function that we're going to time. Now, time it empty. So this is my format string, my literal context. I'm not timing anything, and I don't put anything in. I have 0 arguments. That's timing the scaffolding time. Time it. Let x equal 1 plus 2. I expect this to be right down there in the, so fast that I can't measure it. Time it multiplies. Let mult x f64 equal 1.5 for I in 0 to 10. X, I keep multiplying x together. X equals times x. So the first time I have x and x squared and x cubed and x fourth, x fifth, and so on. And I discovered I have to make this pretty close to 1 or it overflows. Even the floating numbers overflow. But anyway, and now time it, sleep 10 plus sleep 10. Here's do sleep 10, do sleep 20. I have 2 separate things. My token tree, it said 1 or more token trees. Okay, and so here I have 2. This is a token tree. This is a token tree. Okay, and now time it, file open, let open file. Now I'm timing the file opening. And here you can see empty is a little less than a microsecond. X equals 1 plus 2, a little less than a microsecond. This is junk noise, Doesn't mean that this is what the time it takes. It just means I can't measure it. Too fast, I can't measure it. Molts, 2.63 microseconds. Yeah, that's probably starting to get fairly reasonable, fairly close to the measuring time. Sleep 10 plus sleep 20, 30.2412. Yeah, that's a good measure. Okay. And this is an error in the timing. The sleep mechanisms aren't exact. They all will give a little bit more time than the sleep time you asked for. Just because, that it's a system call. They got to make that thunk down into the kernel and then thunk back, and then return back up. So it's time to do that. And then file open 139.47 microseconds. So cool. So this is both a really nice example of variadic macros, variadic in the arguments and variadic in the expansion. Okay, and also it has the beauty of being useful. Okay. By the way, I stole this from somebody else. I modified it a little bit, but I stole it from a blog entry. I've got a reference to it down below. So token trees TT may include tokens that are not expressions like identifiers. I could have put in here in main, I could have said let x equal 2, and I just said time it x. And what it does is, there's no invocation there at all. Okay, and I could have ruled that out. I could have made another rule that just didn't allow a single identifier, or any identifier. But I chose not to, because if you run this with just a single identifier, what happens is you get a warning. Let's go to the playground. So, so here, I'm going to add this. Now, I'm timing this identifier. That doesn't really make sense. So let's run it and see what it says. So it gave me my answers, but it said, warning, past statement with no effect. Okay, cool. So rather than add a rule to avoid it, the warning is just fine. It does what I want. So why would I do anything else? Why would I add code to probably make it less useful? So, okay. Here's another example, useful one, macro for creating hash maps. So here, macro rules hash map, and this is variadic again. Here is my 0 or more of these values, and that gets expanded into, I created the hash map, and then I insert as many key value pairs as there are. So here I have, when I use it, let map equal hash map, 0, 0, 1, 1, 2, 2, and so on, and here's what I get. So, like the vector macro, same model, works the same way. So, cool. And here's some standard macros, assert equals, you've used those. I haven't used the debug macro, and I meant to use it and show you what it does, because it's actually fairly useful. Because it prints out the value of a variable and the line number and the program where it's running. So, kind of useful. So, anyway, there's a bunch. One final thought here. There's a problem you can get into that I'm illustrating here. I've got a show compare one, and this is really, I'm not doing anything useful here at all. What I'm doing is I'm saying, do these things compare as equal or not? Do these two things, left and right argument. So, for example, here I have let A equal string from a string, let B mute A equal clone, B push string. So if I push it, they're different, and it should say they're different. Okay, a string is not equal to a string and another, and so on. But this was really done to illustrate this. This show one works for copy types, but it doesn't work for move types. It works for move types, But what happens is that after you've run the macro, those move types are no longer available. They're no longer value. And you don't want your macro to do that, you know? Not a good thing. So you can avoid that simply by, in the match, the only difference between here is in this match statement, instead of having the left and right arguments, I have references to the left and right arguments, and so they don't get moved into the match. That's where the move happens when you enter that match. Okay. So cool. And so if we come down here to the playground, let's run it. Now, what I said here was compare S2. Let's say compare S1. Compare 1. Now I get move problems, okay? Because, and it's only because of these two guys here, okay? And let me show you that for sure, and then we'll talk about what just happened. So what's going on here is these guys, if I don't use, these guys are what use that moved value. So if I don't use them, you know, the compiler will be perfectly happy with what I did. But if I try to use them, then it'll fail. Now, let's, still with compare 1, let's do for a copy type and get rid of this move type. And I was perfectly happy including these prints because copy types don't become invalid when you pass them by value. Now, let's see. Yeah, let's just do one more thing. And the vector results are exactly the same. So now, and I'm going to do compare 2. So now let's just, so we saw what happened here. They were different. And now if we don't push, they'll have the same, they aren't the same objects, they're different objects, but they have the same values. Same stuff stored on the heap. It's telling me I don't need the mute. I want the mute for the other example. Okay, so I can, let's get rid of that. And now we'll say allow. And also, if you want this, the way these declarations work, if you want to use them at the top of your file, you have to use this exclamation point after the pound sign. If you're willing to put them right in front of this offending statement, then you don't need the exclamation point. So let's run it now. So now it says the string is equal to string, and it didn't give me the warning or anything. So Alrighty, so that's macros. Cool. This guy, if you get serious about macros, this Rust reference is always a good place to look. And this macros by example, he gives you the BNF productions for building macros. Okay, so it's nice and precise. Okay, he's telling you exactly what's going on in a very clear way. So, that's worth looking at. A lot of times you might want to build a crate that has, you got a bunch of macros you defined that you like to use. You can import them. And this, I haven't shown you how here, but if you look at that link, importing macros, a very simple direction. It's basically, there's a new way of importing macros, mildly new way of importing macros that's was added for Rust 2018, and this tells you how to do it. So, it's just a question of the statements. Basically, the macros are treated as a module, and so it's easy to do. Time it is where I stole the timer example from. I added some to it, changed it a little bit, but macros in Rust has examples of both declarative and procedural macros, so for what it's worth. So that's macros. Any questions about that before we move on to one more topic? I want to talk a little bit about debugging. How many of you have been debugging with Visual Studio Code? Anybody?
Not me, Professor, yet.
Good. Let's talk about how you do it. It's really not bad. Really, really not bad. So I put this together. What you need to do is you need to add plugins for Rust and for this code LLDB is a plugin for the makes the LLVM debugger available to you. Create a new Rust library package, populate the package with a small amount of Rust code, start debug sessions, start with debugging, and you'll get some. So the idea of starting a new Rust library is to show you that you don't have a launch JSON. And launch JSON is what tells, there's a built-in debugger in Visual Studio Code, and its launch is just for Node. I think Node is the only thing it knows about natively. But the code LLDB, so what happens is these two plugins, Rust and code LLDB, conspire to provide you the facilities you need, and when you try to run with debugging a project that doesn't have a launch JSON file, these plugins will create it for you. And the nice thing about it is it creates everything that matches your configuration, So I'm suggesting you do it for a library and separate examples, because that will instrument every single one of those as a separate testing mechanism. So let's see how all that works. So you add these plugins. Here's the Rust plugin and code LLDB. There's several different debugger plugins. I would strongly recommend code LLDB. I haven't had nearly as good success with the others. And there's two competing Rust and Rust Analyzer, and I am vectoring. sometimes when you have both of them enabled, you get some conflicts going. And so, the Rust just is a little simpler. It just works. Rust Analyzer tries to do too much for you. This Rust is just what you need, plain and simple. So, nice plugin. So here I'm creating using Cargo new testDB, library, and then name test underscore DB. So this is the name of the directory, and this is the name of the library. And Rust always wants this to be snake case, lowercase with hyphen separated. And then I made an examples directory. And then that created the lib. Now, and I created examples directory, and now I populated them with test1.rs and test2.rs, and I added a little bit of code to the library and added a little bit of unit testing stuff. Okay. And there's no VS directory because we haven't opened VS Code in this directory yet. So here's once I do open it, I get a VS directory, but I don't get, well, I'll get a VS directory when I exit, I think. But I don't have a launch yet. So come on, let me make this. There we go. Okay. So now, this is just code. I added a little bit of silly little code. It doesn't amount to anything that I added. And a few little simple debug tests in the library. And I added some test code. Just all they do is invoke that type, start up that type. So now I open this run, clicking on run, and I click on start debugging. And what I get is a pop-up that says, yeah, I can't start debugging because there's no launch configuration. You click OK, and when you do that, here comes the plugins to your rescue. You get a pop-up that says, cargo from Toml has been detected in this workspace. Would you like to generate launch configurations for its targets? You say yes, and it's going to give you configurations for everything here, as we'll see. So now what I get here is, type LLDB, blah, 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 blah. So this configuration is for debug unit test in a cargo. So it says basically test live package test. It's just like you saying cargo test. It's exactly equivalent to you saying cargo test. And I have no arguments on the command line, but you can give it to them if you wanted to. And now here's a test one. So name debug test one. And now the arguments are build example test one, package equal test DB. And I could have added more arguments here if I wanted to. If it needed arguments, I could just add them right in this args thing. So what it's done is whatever you have in that directory is going to try to instrument it. So you can now debug right out of the box. You don't have to add a binary name. You don't have to change a path, nothing. All you got to do is click run with debugging, and now this is a run to end. This is a step over, step into, step out of, restart, stop. All the usual things. Here you are sitting, here's a breakpoint. I put a breakpoint. If you didn't have any breakpoints, it just runs all the way through to the end, just like Visual Studio. So I put in a breakpoint, and you put in breakpoints just like you do with Visual Studio. You just click in the margin, and that'll add a breakpoint. And so, away you go. And now, it's telling you about the call stack and stuff. as you're down here, now you can see I get to see some of these types. So what's my arg? A string. What's arg2? 0. It's telling me what I got here. Okay. Now I gotta say that the visualizer doesn't work as well as Visual Studio. Visual Studio, you can see anything you want to see. But in this debugger, there's some values it just doesn't want to show you. It likes to show you members of structs. Okay, so, you know, it's not that you can't see some of those other things, but you got to kind of play around with it to get it to show you stuff you want. And some, I've had stuff, I really wanted to see that value, and I couldn't figure out a way to get the visualizer to show me that value. That's where the debug macro would come in handy. Just add in the debug macro, and it would print out the value, and then you'd see over here, you'd see the value. I point. You can't see me pointing, but I'm pointing into the terminal panel. It'll print out the output of the value. Okay. So really, it isn't a bad debugging experience. Is it as good as Visual Studio's? No, but it's a fairly close second. You know, not bad. I got to tell you, with this debugging, I'm doing most of my code development in Visual Studio Code now. I use Visual Studio mostly for managing my website, for writing HTML and JavaScript. Not that I never write C++ code or C# code, you know, but I'm very likely to write it. C++ code, I use CMake to help me build stuff. And in Visual Studio C#, I use .NET, the .NET command line. And between .NET for C# and CMake for C++ and Cargo for Rust, the workflow is almost identical for all three languages on both Windows and Linux. And that is a big, big, big plus. Okay. Really, really worthwhile. Okay. So I'm about done with what I wanted to talk about, other than I want to talk about the extensions. So for the next 2 weeks, you're going to be pulling everything together and trying to get TextSearch to work, if you haven't already. We talked about doing, in step 5, adding regex for the TextSearch, and I think that's a real easy thing. I don't think that's going to be very hard to do at all. I already did it with my original Rust TextFinder, so and I didn't go back and look at the details, but I don't remember it being at all difficult. The other thing, the other extension is to parallelize this parallelize this text search. Can you guys see that okay?
Yes, Professor.
Okay. So what's going on here is in text search, I've put a thread pool. And each thread is searching a single file for text. And DirNav just works just like it always did. This is probably the main thread. It's just working like it always did, pumping files and directories into this queue. And these guys then react accordingly. When they get a directory, they save it away in a current directory folder. But you got to be careful now, because this guy might still be working, might have a big file, and he's still searching it while somebody else has pulled out a new directory. And so if he goes and changes that current directory, when this guy finishes up, if he grabs the current directory now, he'll have the file in the wrong directory and send that to display. So there's a little bit of, you got to think about it a little bit. I don't think it's too hard to work all that out, but it's going to require a little bit of thought. The other thing is that this guy, display, needs to know when he's done. And the model for that is, one thing we could do is using an atomic, just create essentially a semaphore. And so every time a thread is created, it bumps up the semaphore count. Every time a thread quits, it bumps the semaphore count down. So what happens here is DirNav, when he gets to the end of what he had to do, he puts in a quit message. And let's say T2 pulls out that quit message. What he does is, before he quits, is he reposts the quit message, and he decrements the semaphore, and then he exits. And then the next guy will pull out that quit message and do the same thing. Repost the quit message and decrement the semaphore. So eventually, all the threads will be stopped. The semaphore count will be 0. This guy will have a quit message sitting in the queue, but that's all. And this guy now, what he has to do is, every time, if his queue is empty, before he goes and grabs something from the queue, he's got to look at it and say, are you empty? If the answer is no, he's not empty, he just grabs the result and runs with it. And then he comes back to get another result. Are you empty? Yes, I'm empty. Now he's got he will bind on that. But if he pulls out a quit message here, okay, so what happens here is, if we let the last guy to shut down, the guy who bumps the semaphore from 1 to 0, he's the only one who submits a quit message to this queue, then when this guy pulls out a quit message, he quits. So now you got a nice termination process. But you really need that semaphore to help you with that. So this is significantly harder than 5. This is session 6, step 6. Significantly harder than step 5 is trivial, I think, almost trivial. Step 6, and there's an interesting question here is, so now I've made my application significantly more complicated. It's got some concurrent processing, it's got some event handling, it's got a thread pool. So question is, do I save enough time to make it worth that complexity? And I'm guessing, I don't know because I haven't done this yet, I'm guessing that the answer will be, it depends on the directories that you're searching. If the directories you're searching have a lot of big files, then yeah, it'll be worthwhile. If they're all little tiny files, then the answer is it'll probably run slower than the original one. Not much slower, a little slower. Okay, so now Vishtasp, can you turn on your video?
Hi, Professor. So today I've joined from my work laptop and the camera
Okay.
doesn't work on
You don't
this
have
one.
it. Okay, good enough. Good enough.
Yeah,
I'm
yeah.
with you. So the question is, should we do these? Are you interested in taking these last 2 steps?
Yes, absolutely. I am.
Okay. Zane?
I think it'll be worthwhile to learn about concurrent.
Well, this will be the first time we've talked about threads. When we get to 6, it'll be the first time we've talked about threads. And there's quite a bit to talk about. The threading model is really interesting. So I think it's worth your time, but you have to think it's worth your time. You know, I don't want to come up here for session 6 and only Mike and I are here. Okay. So, so it's you know, it's up to you.
Um, I think from my perspective, I think this model is actually very helpful for the text search. It's just like the current situation. Just we are doing text search, but what if like a web crawler, like we can like put this model in a web crawler
Oh yeah.
context. Like
Yeah.
our task is searching for the entire web. So like we definitely need like multi-thread those kind of stuff to do this task, right?
Yeah.
Yeah,
I
I think it's very
agree.
helpful.
Yeah, this model applies in a lot of places. Web crawler for sure. Yeah.
Yeah,
Okay.
yeah.
Vaibhav, are you interested?
Yes, Dr. Fawcett, I'm running.
I'll put you on the spot.
Yeah, I'm running behind, but I'll catch up this whole week, and I'll
Okay.
be ready for this session
All right.
whenever you decide.
When a presenter asks that kind of question, there's only one answer he's going to get. Nobody wants to say, "Nah, it doesn't sound interesting to me. I don't want to do that." Anyway, all right. Well, I'll plan on continuing with these two, and I doubt that I'll do I think the presentation in 2 weeks will be fairly short. I'll talk about regular expressions and talk about, you know, cheat sheets and a little bit about how the language works. Not in detail. It's complicated but usually all you need are the very elementary parts of it. That's the most useful. The most useful 90% are in the simplest 10%. But
Yeah.
the sixth session, definitely the sixth step will definitely be a longer talk because it'll take a while to talk through the threading. All righty. Are there any questions before we quit today?
Great, Doc. Thanks.
Yeah. Vishtas, did you get what you wanted out of the macro part?
Yes, Professor.
Okay.
Absolutely. Yes.
Again, what else could you
It
say?
was great, really easy to follow along.
Okay.
No, seriously, it was very easy to follow along, and I'm just amazed that it seemed like such a complicated topic, but you presented it so simply that, you know, yeah,
Good.
I think I pretty much understood
Okay.
whatever the explanation. Yeah.
I have to tell you, it takes a lot of time to be simple.
Yes,
It takes almost no
I'm
time at all to
sure.
be complicated, but it takes a lot of time to be simple.
I agree, Doc. That was, I didn't look at the macros at all yet until you described them. And at first look, I thought the syntax was a bit cryptic, but it was helpful to see, the way the expressions they repeat. Your explanation, I think it saved me a lot of time. I would have
Good.
spent a bunch of time debugging that or decoding that for myself.
Okay. One other thing while we're here before we quit, Mike has looked at this and he says he likes it. I put up in a repository with links to playground code. Everything that was in my little animations thing, the features animation, is here, and some of the stuff from our previous sessions is here, and some of the stuff from the Rust Bytes is here. And my plan is to keep this up and keep adding to it. So every time I do some example code, if it isn't well represented here in this list already, I'm going to add it to this list. So the idea is it's easy to find, easy to get to, pops right up. So let me show you how you can find that. If you go home and then sitemap, here it is, Rust Playground examples. This is the features thing. I'm going to remove this features eventually, but this just takes you to these examples. Alrighty. So with that, I think we will say sayonara. We will have another session in 2 weeks, Friday, 2 weeks from now. If that turns out to be a bad time for any of you, let me know. We can always juggle the day or the time. That's not a problem. All righty.
Thanks, Doc. Fantastic.
Thank you, Professor.
You're welcome.
Thanks, Professor.
Thank you,
Yeah.
Professor.
Thanks,
Thank
Professor.
you guys for participating.
Mm.